Okay, so here we have a problem. We have a lead ball that is dropped into a lake from a diving board that is 5 meters above the water. So after entering the water, it sinks to the bottom with a constant velocity equal to the velocity that it had when it entered the water. Right, so that's the problem. So the ball reaches the bottom 3 seconds after it was released. So how deep is the lake? So this problem seems like very difficult. So what we are going to do is apply a recipe, prepare, solve, and assess. So let's start by preparing the problem. So what do? Well, let's draw a picture. Let's draw a picture to start making sense of what we are being asked. So we have the lake here, right? And we have our diving board, and then this is the ball, and the ball is dropped and enters the water. So one important point is when the ball is dropped, when it enters the water, and finally this is the bottom, and the ball reaches the bottom. That is the 3 important points. So let's choose a coordinate system, and I'm going to choose a coordinate system that I'm going to put my origin here at 0, and then everything that points up is positive. So gravity is going to be, the acceleration of gravity is going to be negative here in this problem. So this is my origin here, and so I'm going to write it origin. And so I have 3 important points, right? 3 important times. I have the time when I drop the ball, so I'm going to label those 0. I have the time when the ball enters the water. I'm going to label anything that has to do with that time 1. And I have the time when it reaches the bottom. And I'm going to label anything that has to do with that 2. So let's start then labeling things. So I have an initial time, an initial position, and an initial velocity at 0. Then I have my time at 1, my velocity at 1, and my position at 1, and finally I have my time at 2, my velocity at 2, and my position at 2. Right, so let's see what we know. We know that at t0 this is always 0. We can always set up stopwatch to 0. We know because of our choice of origin this is 0, and we know this is 0. So we know those 3 numbers. So let's see at 1. T1, well, we don't know what that is. We might need to find that. V1, we don't know what that is. We might need to find that. And Y1, because of our choice of coordinate system, this would be minus 5 meters. Okay, so that is Y1. So T2, we don't know what that is. We might need to find that. V2, we don't know what that is, but we know one thing. We know that it's V1 because the acceleration in this segment is 0. And Y2, we don't know what that is, but that's what we need to find. So accelerations in this segment, you have G, and in this segment, and I'm going to call the acceleration here, I'm going to call this A0, which is minus G, and here I'm going to call this A1, which is 0, right? So if I draw a motion diagram for this, it would be the velocity increasing, and then after that it goes at a constant speed, right up to here. These arrows here are supposed to have the same length, so maybe not because of my drawing, but they were supposed to be with the same length. So let me just erase this motion diagram and try it again. So this is velocity increasing right there, and then after that constant speed. So constant speed from here to here, and increased velocity in the other segment. So now let's see how we solve this problem. So we want y2, right? So y2 is, we can write this equation, y2 is equal to y1 plus v1 t2 minus t1 plus 1/2 the acceleration on that segment, t2 minus t1 squared. So now this is 0. So then y2 is equal to y1 plus v1 t2 minus t1. So we don't know a bunch of things here. We don't know t1, we don't know t2, we don't know v1. We know y1. So now let's just try to write an equation for y1. See if we can find any of these things. So y1 is equal to y0 plus v0 t1 minus t0 plus 1/2 a0, the acceleration in that segment, t1 minus t0 squared. And then I can simplify this whole thing. This is 0 because the initial velocity is 0. This is 0 because the origin, we chose that to be 0. And I get that y1 is equal to 1/2 times minus 9.8, which is gravity, right? And then t0 is 0, so this is t1 squared, right? So then I can solve for t1 here from this equation. I can solve this for t1. And then we know y1, right? So y1 was minus 5 too, right? So this is minus 5. So the minus cancel. And I can solve for t1. And I get that t1 is equal to 1.01 seconds. So I know now this t1 here. So now I can go ahead here and put t1, and then I would need to find, so let's see what else we need. We need t2. But we know t2. We were told t2 here. So when I wrote my things that I know, this t2 is 3 seconds, right? Because it says 3 seconds after it was released. 3 seconds after it was released, it hit the button. So t2 is 3 seconds. So yeah, so I knew t2 from the beginning. Sorry about that. So now I can go ahead and solve and use this equation here because I know v1. I can find v1. I know t2. I know y1. So let's just see how we find this equation. So let's start by finding v1. So v1 is equal to v0 plus a0, the acceleration in that segment, times t1 minus t0. So that's how I find the velocity here, right? So 1 becomes my final and 0 is my initial. So v1 is equal to 0 plus minus 9.8 t1, which is 1.1 second, right? So I can put 1.01 seconds here, and then I get that v1 then is minus 9.898 meters per second. Right, so that is the velocity that the ball has when it enters the water. So now I need to find the position y2, right? To find y2, I use this equation, and now I know everything because I know t1, I know t2, I know v1, and I know y1. So I can write that y2 is equal to y1, which is minus 5.0 meters, plus then minus 9.898 meters per second, right? That is v1, plus t2 minus t1, so it's 3 seconds minus 1.01 seconds. And then I can solve for this, and I get that y2 is equal to minus 19.7 meters. So how deep is the lake? Well, the lake is y2 minus y1, right? So sorry, this number here is 24.7 minus 24.7 meters, and y2 minus y1 is equal to minus 19.7 meters. This is how deep the lake is. So I hope you get an idea of how to solve these problems. When you get a problem that looks intractable from the beginning, just start by drawing a picture, defining your important points and labeling things, and see what you know and see what you need to find, and then go onto your tool, your equations, and see which equations you have to use and you have to rearrange to solve your problem.